All right, we are now on to lesson 2.5, part 2. I want to make sure that I go over examples 4 and 5. Starting with number 4, it's going to introduce the natural base, which is often represented with the letter E, the same way that pi is represented by the pi symbol, 0.31 t power. And it says that t is measured in hours, so I'm going to put t equals hours. So here's everything we know from this problem. Um, I want us to think about how can I rewrite this so that the only thing in the exponent is a t, because that would be a times b to the t. So I have to manipulate this. I've got my 17 out front. I've got Euler's number to the 0.31, which is then raised to the t. So if I can figure this out, that will be my b value raised to the t power. In order to find that, I just use my calculator, press second, and then this third button right here brings up e to the exponent. So we're going to use that and then raise it to the 0.31 power and press enter like that. So this becomes 17 times 1.363 t. So this is our new function for b of t. It's truncated to 3 decimal places. However, if I were to do math with this, I wouldn't use that number. I would use this number by copying it, by highlighting it and pressing enter. Use that number again so that you get more accurate answers. The next part of this question is guaranteed to be on your AP tests. It asks you to find the average rate of change. Now, we did all of this and we're going to use some of it, but it's asking me to go back to just the basics. Average rate of change, change in y over change in x. And then they're using values of 1 and 7, 1 to 7 hours. So that's my x 7 minus 1. Now I need to know what are the y's, what are the outputs. So let's really quickly plug in to this equation. You could use the new one or the old one, but make sure you're using that value. Try and find those outputs. All right, double check. Are these the values you got for your outputs? If you didn't get these exact values, maybe double check and make sure that you are using the previous values. Now, notice that I have that 148 right here, but I have the entire number without truncating. What I'm going to do with this is use that and then just press minus. It brings that answer down. And now I want the exact second value. So I went up to the 8, highlight it, press enter, and you'll notice it brings that number down. So you get the most accurate answer you can. I'm going to press enter and I get 140.132, and it continues, and then I'm dividing that by 6. So I'll just press divided by 6. It copies my answer. And our final answer here for the rate of change over that interval is 23.355. That's the average rate of change over that interval. So here's the thing. Average rate of change is linear. So that's a linear answer between 2 points on an exponential graph. So that's the slope between those 2 points. Now, the last part of this asks us to predict the number of bacteria there will be after 15 hours. They like to jump around on the AP test. So we did this rate of change, but now I'm not actually going to use it for part C. Part C is calling back to this one. So let's go ahead. They want to find 15 hours. So I go ahead and do B of 15 is equal to 17 times 1.363 to the 15th power. Go ahead and plug that in. Let's figure that one out. All right, everybody, take a look. The answer here was 1,769 and 647 thousandths. Depending on your rounding, you might have been slightly different. But let's go now to example 5, which I'll put on the screen here. This is talking about 50 deer and it gives me a times b to the x, where t represents the years. So I want to make sure I highlight t as years, and then the population increase of 13%. I want to remind you, 13% is in addition to the 100% that already existed. So this would be 113%, which I can then convert to a decimal. So that would be 1.13 for my R value. So they gave me the R value. That's super helpful, or rather the B value. R, I was thinking back to geometric sequences, but that'll go in for B. I want you to actually try this one out on your own. I'll share the answers, and then I'm going to discuss letter C. So hold off on that. All right, take a look here. A, I wrote my equation. This function, d of t, I noted t was years. It's good to define what that variable means, especially based on what we're going to do in part C. We have 50 times the 1.13, which is the 100% plus 13%, because it's growing beyond 100, the existing population. T was time in years. So then in part B, when they said define 6 years, I plug in 6, and this was what I calculated. Now, part C is where I really want to focus. Part C says that they want you to rewrite it where you can plug in months instead of years. So I want you to think about this. If you have years, which they defined as T, I'm going to put M will be equal to months. And I want to think, if I've got years in T and months, how do I get from years to months? Well, 12 times 1 is 12. So 12 times the number of years gives me the months. But here's the thing. The equation you're solving by plugging in T. So I got to get rid of this, isolate my T, because if you think about it, the number of years is equal to the number of months divided by 12. 24 months divided by 12 is 2 years. So we've got m over 12 is how you'd write t in months. So when I write my equation, it would be d of m is months is equal to 50 times 1.13. And then you would, instead of putting t, you would say months divided by 12. And that's a great answer. But I could take this a step further. I could take m over 12 and split it up so that 50 times 1.13, that's not negative, is equal to 1/12 times m, right? So this is essentially an exponent raised to an exponent. 1/12, dang it, can't see it. 1/12 times m, right? Because m twelfths is 1/12 of m. So now I could actually do 1.13 to the 1/12. And I'll do that on my calculator. You should do that as well. 1.13 raised to the 1/12 power. So my answer there is 50 times 1.010 m. So now I've converted the B value so that it is written in terms of months instead of years. Let's check this out. Let's try it. If I plug in 12 here, I would have 50 times 1.010 raised to the 12th power. And I plug that in, I got 56.3. That's for 12 months. Let's go back to our previous equation. What if I do this equation, but for 1 year? I would do 50 times 1.13 to the first power. And that also gave me 56. Now, there's a slight difference there. That slight difference is because I rounded, or truncated, rather. If I hadn't truncated this or that, I would actually, this wasn't truncated. If I hadn't truncated this, though, they would have the same exact answer. So once I have my equation written, you can rewrite time, years, in terms of months, and then plug that in and replace the previous exponent with the new exponent, split it into two, and apply one of those two. So you're going to see this on your practice. Make sure that if you have any questions, you write them down.